a little discombobulated or worried, you didn't get this done or you didn't get that done, because you didn't have the book to take home and freaking out and you hate Larson Hofstadter and you can't you just do Saxon and all. I'm with you. All right. First of all, that idea of I hate Larson Hofstadter, I want a Saxon, that's always, even when I check out Larson Hofstadter. Second, I'm never really absent very much. This year's different for me, so don't worry. Everything will be fine. Okay. Some didn't get everything done because they couldn't take the book home. Fine. I will grade the first few homeworks based on basically did I get a paper from you and was there math on it? That's it. If you can say thumbs up to that, then good. If you can't say thumbs up to that, wow. We'll get in a good groove here starting really tomorrow. Today I'm on that stage, but I'll do my best today, and everything will be fun, don't you worry. Starting tomorrow, I'll have a limit overview of, look, this is every limit problem I can think of. Can you do these? Anything you don't feel comfortable with, we'll get better at until you can do every limit problem I can think of that's appropriate for your level. You still have some limit ideas you don't know that we'll come to list it, right? So don't worry, and then we'll get on awesome footing going into derivatives. After we'll start to get into derivatives, and then we'll actually start to do calculus. We'll get further and further, and you'll feel more and more comfortable. All right. So if you're not quite settled and you feel kind of all over, it'll be done. All right. So do you have this in front of you? Did you pick up this from the back? Okay. This is a bit of a hodgepodge. Mostly it's a pre-calc to a textbook, and so it's limits, the intermediate value theorem, little sandwich theorem, and a little side trig, my preference kind of thing. So this is a bit of a potpourri. Let's start with this idea. For the most part, you guys will absolutely just kill the limit questions. There are a few that tend to get students, and so I want to make sure that you have seen those also. Let's talk limits. When you talk limits, infinity, and asymptotes, they all kind of go hand in hand. So let's start with the idea of a vertical asymptote. Wouldn't you agree at a vertical asymptote, x is approaching some actual number, and y behaves infinitely, whether it be positive or negative is not important. And so it feels like if it's the case that you have a limit as x goes to a constant of some function and you get infinite behavior, or negative infinite behavior, then it must be the case that there is a vertical asymptote. Those go hand in hand. So if you don't have a picture, you don't even know a function. All they tell you is that this limit thing is true. X goes to a constant, y goes to infinity. You can be confident that means there's a vertical asymptote there. You don't know what the graph looks like, but I know that. Likewise, if you have a horizontal asymptote, it's the other way around. Instead of x going to a constant, y behaving infinitely, it's x behaves infinitely, y goes to a constant. So it would be more like the limit as x goes to infinity, or negative infinity, if you approach a constant, then there is a horizontal asymptote. Would you write yourself a note, please? You need to check both sides. Okay, it is possible for a graph to have two totally different horizontal asymptotes. Just because you might not be able to think of one, an equation doesn't mean there isn't one. So for example, if you look at this, does that have
that have vertical asymptote? Yes. Yes, how many? Feels like 2 because there are no common zeros. There's 2 denominator zeros. It feels like 2 vertical asymptotes. Do you agree? Okay. What about end behavior outside asymptotes? When you talk horizontal asymptotes, you say, well, as I take x to infinity, what happens? What is the end behavior? As x goes to infinity, this approaches negative 1/2. Would that be different on the other side? It would be the same. Right. So in this case, it would be the same on both sides. There would be a horizontal asymptote at y equals negative 1/2 on both sides. Was cool? Like I said, sometimes they get tricky. This was on a CU exam last year. Let's go. Does this have a vertical asymptote? What would I do to investigate that? I'll do the right. You tell me what to do. 4 minus 3 to the x equals 0. 4 equals 3 to the x. What now? What's the inverse of 3 to the power? Log base 3. Okay, so log base 3 of 4, log base 3 of 3 to the x is just x, yeah. So yes, there is a vertical asymptote at log base 3 of 4. What is that about? Let's make log base 3 of 4, please. What's log base 3 of 3? What's log base 3 of 9? So 1 points up. You agree? All right, so there's vertical asymptote at x equal log base 3 of 4. Let's talk end behavior. I told you, the whole point of this with talking over here was that you need to check both sides. Even if you don't write it, you need to think it. As x goes to positive infinity, do you agree that these are the dominant terms in terms of end behavior? The 4's mean very little. And so what would that approach? So can you see the sign in front of that? So what is it? Negative 1, right? Do you agree? Okay. The limit as x goes to negative infinity. All right, so what is x is an exponent in this case? What does a negative exponent mean? Right? So what is 3 to the negative infinity approach? What? 0. Okay? So this approach is 0, this approach is 0. So what is that approach? 1. So my point then is there are lots of graphs. It's not super common, but it takes some work to come up with one. As a math teacher, I can tell you that. But it is possible that you have end behavior that's different on both sides. And so to really cover your toes, you should at least think both sides. On a rational function, where it's algebraic terms, the powers, that's never too different. It's always the same. But there are functions that are different. Understood? Okay. All right. Would you look at 15? This is a multiple choice question. It sometimes gets people, probably not you with your genius ability. It would get me, right, Jerry? I don't need to see any work for that. If you just expressed your answer or circled an answer, that's fine. Listos? We've got 1 more minute. Ready? Okay. So, I'm visual, so I did do a little work here and there. 1, 0, I don't know if that means much. Equals 3 is asymptote. Excuse me, so it's that. Fight the temptation to connect the dots. You don't know what's going on between those two things. Must it be the case that f never meets the line y equals 3? True or false? You're telling me a horizontal asymptote can be crossed? Yeah, that's what you're telling me, because that's true. A horizontal asymptote can be crossed. That's true. And so it's because it is possible I crossed a horizontal asymptote. I don't know that this is true. It's possible it did pass through that point. So this is false. Okay? Must it be the case that as x goes to infinity, y equals 3? Yeah, that's what we were talking about right there. Those two things go hand in hand. Horizontal asymptote means the limit approaches the constant, in this case 3, right? So that's a true. Must it be an increasing function? I just threw you a bone there. I mean, could it be? They're basically trying to, the gotcha to this question is they're trying to get people to just connect the dots, read too much into the function. So if they do it that way, then look at their picture and took that to be Bible truth, is that going to mislead them yet? I mean, so in this case, but is it really true that it has to be this way, or could it? And so did you say B? All right, cool. All right. Pause for a second from limits and such, and we'll come back to that in a sec. But let's go back to pre-calc. I'm a little picky about how I ask you to graph sinusoids. This has to be kind of an undoing of Saxon here. And Miss Cannon might have fixed this already, but I'll just make sure here. So tell me, if I asked you to graph y equals x times x minus 2, would you say, okay, so that's a parabola, and now let me figure out where the axes are? Is that how you would graph it? Of course, that's ridiculous. The first thing you do is put the axes down. So tell me then, why would it make sense that if I go to graph this, that I would first draw a sine wave and then draw in, no graph, sine or otherwise, do you ever draw the graph then the axes? That's a no. You draw the axes, choose a scale, and graph the graph. In all graphs, and sinusoids are not different than that. So when Saxon teaches in set 83, draw a wave in space, all floating around, and then figure out where to put, no. Okay, you start with the axes, and then you choose scale, and then you graph. So, me, before I choose a scale, I would kind of want to get a feel for what a rough draft of this looks like, starting with the period. The 2 and the 3, do you agree those are vertical components and center line? And that's not a big deal. Most people are fine. The horizontal part, do you remember how to find the period of a sinusoid? Which does it have to do with? The period has to do with the pi over 2. What do you do with that pi over 2? The period. 2 pi over pi over 2, yeah? So the period is 2 pi over 2, which means the period is 4. That's delightful. Now, in terms of preference, I expect sinusoids to be graphed over the entire space provided accurately at every quarter wave. All right? So I don't expect, some teachers say, you know what, I just care that the wave has the right period, and up here and here I don't give a rip what. I care. That's garbage. What the heck? That's not even a function. Are you kidding me? Jeez Louise. So I expect that you would know where this is, and this is, and this is. Those quarter wave points everywhere over the whole space provided. Now, I understand there's a shift there, so those aren't set in stone yet. What is the shift, left or right? Left. Okay. So this will be more like a starting point, quote unquote, of -1 and 0, 1 and 2, 3 and such. I have a feel. I just go until I feel like, I understand. Looking at those numbers, what kind of scale along the x-axis would I choose so that I can locate those numbers? What would you go with?
question. I can give that to a pre-algebra kid. I go by ones, actually. I can't go by ones, okay? Now, where you put that one is kind of up to you. If you go one box to one unit, your graph will be accurate. Will be a pretty tight wave. It'll be pretty tight considering that you're going up 3 and down 3. It's going to be pretty squished, yeah? I think and I wouldn't be wrong if you did that, but I think a cleaner picture would be a little wider. So I'm going to go 2 boxes to 1 or a half, I suppose, if you like. Vertically speaking, I can't do that because I need to be able to get a max of what? 5. I need to be able to get 5, and going by halves or 2 boxes isn't going to cut it. So vertically, I'm just going to go by ones. And that should do it. After that, I kind of get my vertical bearings. The center line is 2 or the center line is 3. Center line is 2, the maximum is 5, the minimum is -1. Those, if you put those in, and I don't demand that you put them in, I just put them in so I don't go too high or too low. They should be dotted, those shouldn't be solid. Solid is for 2 things on a graph. The axes, or points that satisfy the equation, right? And surely those don't all satisfy the equation. So now we go to the left one, and it's at the center, yeah? And we said that every quarter wave is 1 unit, yeah? So I could go here and go 2 boxes, and I would be at a max. And then I could go 2 more boxes, and I would be back to the center. 2 boxes mid, 2 boxes center, and at that point I'm pretty close to off the graph. Likewise, I could go backwards. When I go backwards, 2 boxes would take me to the min, right? 2 boxes middle, 2 boxes max. And graph over the entire space provided. Okay? I'll say it one more time. I demand that the graph go to the edges of the space provided. When you graph, you're telling me 2 things. What points satisfy the equation and what points don't satisfy the equation. And if your wave is only this much, then you're telling me there are no points that work in the equation. And that's not true. There are points over there that work. All right, so you must graph over the entire space provided. Is that clear? Okay, cool. Oh, I did not mean to. Oops, I did not mean to do that. I really need to work on my coordination. Is this the next question? Is this next sandwich theorem? Okay, cool. This is terrible. So would you please change? Would you change this to? Look at it. Oh, yeah. G is greater than H, but less than F, which is another way of saying that is H is less than G is less than F. Understood? And then also, H is garbage. Would you scratch out the 2 minus and just say H is cosine? I don't know what I was thinking when I made this. It's just a mess. I apologize. All right. Now, this is an idea of limits that's very intuitive. The temptation is to use graph as justification, and I want to warn you against that. So I want to express how I want the work done analytically. First, write that. Graph is to help you prove analytically or justify your work analytically. The reason is that sometimes these problems don't have a graph, you can't graph them, and then you're something. And so your primary method isn't even there. Analytically is the way I expect you to do this. All right. Now the question is, what is, as x goes to 0, what does g approach? Well, that's great, but they don't even tell you what g is. How am I supposed to know what g approaches if I don't know what g is? Well, that's where how they relate to each other in space and the givens kind of come together. Now, we'll use the graph kind of to illuminate, but it won't be our actual justification for all work. X squared plus 1 is a parabola shifted up 1, as you know. And cosine. Let's do that in a dotted kind of fashion. At 0, where's cosine? 1, and it goes like this, right? You agree? Now, what about H? G, rather, excuse me, G. Well, G, I don't know what it looks like, because they never tell me what it is. But I do know that for every point, the y value of G is between the green function and the blue function, or cosine, the sinusoid, right? So it might look something like this. But, and it could be lots of different things out here. But when we get to 0, can it be lots of things, or does it start to get sandwiched, squeezed between the two functions? And that's really the heart of the idea of the sandwich theorem. Visually, what does it look like, the answer to this question? So it has to be 1, because the above and below have to be 1. Now, that's really what the analytical work should look like. Start off analytical justification should start off with what's given. G of x is between h of x, and I call it an h. You could actually put the functions in if you like, that wouldn't be terrible. Okay? Now, if this is true for all x, if it's true for all x, which it says it is, then it must be the case that in any fashion we approach, it must be true. It's true for all x, including approaching 0 x's. I'm trying to get, this is the question, and I'm trying to get at what's the limit of G in there, and I need the limits in there to answer that question. Now I want to find the outside limits. H of x, we said, is cosine. And what does cosine approach as x approaches 0? 1. The inside I don't know, that's the question. But I do know the right side, or the upper function. As x goes to 0, what does x squared plus 1 approach? 1. Well, if what they're asking about, the limit as x goes, that's x goes to 0, not h, you've done that. Thinking the definition of the derivative already. The limit as x goes to 0, g of x is greater than or equal to 1, less than or equal to 1, so it's got to be 1. The limit as x goes to 0, g of x is 1. Sandwich theorem. Boom! Are you with me? Cool. All right. Let's go to the intermediate value theorem. Abbreviated IDT. There are 3 existence theorems any calculus student should learn by the end of Calc 1. The intermediate value theorem, the mean value theorem, and the extreme value theorem. They're all used to answer, must there be a place where this happens? So these problems are not, 17 is the answer. You're trying to more like justify the existence of something. No existence of it. All right. The intermediate value theorem on a layman's sense would be, if I got into an elevator on the 1st floor and went to the 10th floor, must I have gone through the 3rd floor? Surely you must have. I don't know if I stopped at the 3rd floor, but I must have gone through the 3rd floor at some point. Now, that's the intermediate value theorem, and there's no worry about me jumping straight from ground floor to 10 without going through in between, because that's my physical existence and it's continuous. But in a more theoretical sense, could I go from a y of 0 to a y of 10 later, but not pass through anything in between? Well, surely there's the possibility of a hole, or there's the possibility of an asymptote. And so, if you recall, continuity is the first condition, yeah?
The second is betweenness. If I told you something went from continuously from a y of 0 to a y of 10, must it have been 17? Must y have been 17? No, I mean, could it have been 17? Close, but the whole idea on IVT is continuity and betweenness. And if those two conditions are met, then the IVT all holds together, all right? So, I just want to see what your work looks like for that first example. Would you try that first example so I can see how your work looks? It doesn't have to be strict. It's not like a paper. You could organize it a couple different ways. Would you do this in one of these two ways or some other way? What is your work look? Will somebody just read their answer just so I know what yours looks like? It doesn't have to be right, even. I don't care. I just want to know. Yeah. Three is less than four. Okay. And then said what else? So in terms of the conditions met, you have to have continuous. So first of all, don't ever fall into the trap of thinking, well, you said continuous already for me, so I don't need to say it. You need to say it. You need to show that's a condition for the proof to happen. So it needs to be stated. You also need to have betweenness at some point. So Brenda definitely had that in there somewhere. I have betweenness in here somewhere. I have F equals. I have seen people just say, 4 is between 3 and 7, and that causes the reader to do a little more reading on their part, but it's acceptable. And therefore, and then the conclusion. Now, actually, this one has a little bit of a flaw to it because I don't cite the theorem. Really, I should say, something like so by IVT. You really should. The AP grades it a little easier than a college professor would. A professor would be asking for continuity, betweenness, and the statement of the theorem, IVT. And if you have those three components, you're in pretty solid shape. Does that make sense? Yes? Okay. The AP1 students typically do well on. I've had a few students come back and say, I took Calc over again because the college requires it or whatever. And this one it was a little harder for me. So, prove there must be at least one solution to x cubed plus sine of x minus 1.2 equals 0. This was on the CU applied math. Test 1 actually. Applied math at CU test 1. Step back. I know I'm saying it's IVT, it's IVT, it's IVT. But step back and think, if you were in these shoes and you were on test 1, it was a mixture of things. You weren't in IVT mode. Would you have known to use IVT then? Prove there must be a place for x cubed plus sine of x minus 1.2. Yeah. Now this is a non-calculated question. And notice the first thing you need to understand is it doesn't say find the place where x equals. It doesn't say solve the equation. It doesn't say that. Not solve, not find the x that's the solution. It does not say solve. It says show there has to be a solution. All right. So that requires you to go at this in a little different way. But if you are good, by the end of this class, you should say, must there be a place where? Then your mind will only go to one of three things. Is this mean value theorem? And they're talking about average rate of change and instantaneous rate of change. I think you guys talked about that over the last year, IVT. Okay. We'll review that. IVT, does it have to be a certain y value that exists? Or EVT, does it have to be a maximum and that's something else? All right. So I read this, and that's what tells me, I got to show that this equals 0 somehow. And if I'm going to use IVT, then it's about continuity and fencing it in. And what's on either side of 0? Very generally speaking. On the number line, on the left side of 0 is negative. Did you say positive? The negatives, right? Pretty sure negatives on the left side of 0? Okay, just want to make sure. And positives on the right side, yay? Okay, so if I could just show it's negative on one side, positive on the other, I'd be good. And is it continuous? And golly, is this possible? Well, let's take it piece by piece. Is it continuous? So you're a little bit at a disadvantage because you're calculator dependent. Back in my day, students love it when old people say that. Back in my day, we would answer that question by what's called thinking. You would say, well, the parent graph to this looks like this, and the parent graph to this looks like this, and that's a shift. If I put those two parents together to make a baby graph, then what would happen? Well, it's just like if I took 1 plus sine of x. Paradigm shift. Change this. Think of y equals 1 as the base graph. Doesn't y equals 1 look like this? And what would sine do to that? In some places sine is positive, and so you'd go a little above 1. And sometimes sine is negative, and so sometimes you go a little below 1, right? Are you with me? Okay. So here, if you think of x cubed as the base graph, then sine sometimes will be positive and make a little bigger. Sometimes sine would be negative and make it a little smaller. But what would those do? Instead of this, it might go something like, oops, there will be a function, but like that, yeah? And then shift it down 1.2. Now, does that feel like it would have a negative someplace and a positive at someplace? Yes? Okay. And do you feel like the combination function would be continuous? Yes, x cubed is continuous, has no issues. Sine is continuous, has no issues. So I feel like there's no issues. So IVT is good to go. Let's get into it. Here we go. Let's start with because this problem is fairly complicated. I'm not going to do this one huge statement. I'm going to need to nibble away at it, all right? So let's let f of x, so I don't have to write this big stinking thing all the time. It's pretty typical to say, you know what, I'm just going to refer to this as f of x, so I don't have to write that name. All right? F is continuous. Now, you have to kind of feel your professor out. If they're just, it's got 5 books, then you would have to justify that. So give me a
bit of the justification for that. F is continuous because x cubed and sine. And that would be sufficient for even the worst professor. Most professors would be just good if you just wanted to just you with me? Next, the betweenness component. This is where it's going to get a little rocky here. Based on that graph, where do you think we could give me an x that I could put in that would come out negative? I'm not asking that you tell me what it equals. I'm just saying that you could be pretty sure it'd be negative. X is -1. I feel like that would be safe. -1, -1.2, that's -2.2, and that even if it was at its most, wouldn't overcome the -2.2. Do you agree? So -1's fine. I would a little bigger. I think I did -2 pi. So this would be super big negative. This is limited. But fine, negative x equals -1. F, let's say this. F at -1 is -1 plus sine of -1 minus 1.2. And I told you, you don't have to say what it equals. All you have to do is say it's negative or less than 0. Give me something where you can be pretty darn sure it'll be positive. 2? Okay, 2 is fine. 2 is 8, rather. 8 plus sine of 2 minus 1.2. Tell me why you think that has to be positive. Sine of 2 is at least, at its minimum, -1. So the minimum that stuff would be is -2.2. Do you agree? And so 8. And so positive, yeah? All right. I still haven't done between this then. Isn't 0 between f at -1 and f at 2? Remember, the whole idea of IDT is to stay continuous and show betweenness of what they asked about. Hey, you're saying, is this place 0? And I said, well, yeah, it goes from negative to positive, so yeah, 0 is in between. And so can I not conclude by IDT there must be an x in where? It's typical to say where you're stating that x happens. X in between. What's the region of x as I look, that I made? What are the endpoints I used? -1 and 2, where f at that x equals 2. And therefore there must be a solution. You follow? Okay. Try the last one on your own. That's going to be part of the quiz. Let's try that. Bless you, bless you.
bit what mine looks like. Again, it doesn't have to be verbatim. I mean, if you have something, you have the key components there, then you're good to go. Are we good? I'll assume by your silence, everything's going great. All right, would you get out your homework from yesterday real quick? I didn't turn up the key, I apologize. Again, still getting my act together, but here we go. Here for, how many of you are seniors? Here for parents this year. When they drop you off, just know they're going to put on a happy face for you, and they're going to say, oh, we are so happy for you. Sit up. They're going to cry like babies when they drive away. They're just going to wail, baby. Oh, my baby. You guys are so wonderful. They're going to miss you. All right. Here we go. Did you get 0 for an answer here? Can you read using a table? Okay, I know from experience, students did. That's a table. When you make a table, it is common that you put it in the middle. Even the slackest teacher expects at least 2 values. I feel like it's solid. Because you're doing a limit, you should show 3. When you do the approach, please don't do it in a linear way, which is to say 3, 2, 1. It's far better and more precise to go by power. So 1 above, a 10th above, a 100th above. On a limit that bounces a lot, it's necessary to do that kind of approach. That's how a table should be constructed well. There is a point to that. I know the graphing calculator, you can look at the graph. You can't do a delta epsilon proof with the graphing calculator. So stick with me when I say do a table, do a table. All right, you'll make me later. 3 here, I don't think that was anything difficult. -2 root 3 over 3, you didn't have to rationalize though. 15, 5, 6 2/3 for number 4. Are we cool? Are we good? -2, 3 here. I expected you to factor there or divide, I guess. If you didn't remember how to do factoring by sum of cubes, then you could have just divided it. 7 you had to rationalize by multiplying by the conjugate. I had 1 over 2 root 2. You never have to rationalize in this class. I don't care if you leave a root in the denominator. Most professors above also would not care. 8 would be -1/4. Clean up fractions. 9 is a famous limit. We'll talk about that more, but that's the problem number, not the answer. The answer is 1/5. This guy, you should have had a table, a graph, and analytical. The graph is fine. The table should be a free version approach. The analytical, you should be multiplying by the conjugate. It's 1 over 2 root 2. If you are one of those people that said, I already did that above, see above, well, you got me. I'm okay with that. Number 11 is 0. Actually, this, oh yeah, that was 0. Is that what you got? All right, this is last year's key, and I made some changes. So 12, what'd you get for 12? I don't have that in front of me. I heard negatives and 0. What? Somebody shout out. -2. Do we agree? Some agree? Give me other answers. 0? Wow. We better come back to that and go over that. All right. This one was a sandwich theorem, which we called about today, but you're supposed to sketch the parabolas and be able to tell the limit. The limit is 4. All right. 1.4, number 3. Did you get 0, 0, 0? All right. I keep hitting new page. That's done. 2. Function is continuous at. There are 2 typical ways to do continuity. Do you say here the limit from the left equals the limit from the right is the point? Or do you say f at a is defined, the limit exists, and f at a equals the limit? The first one or the second one? Excellent. The second you said? That's excellent. Okay, so f at a exists or is defined is fine also. The The limit as x approaches a exists. What does that imply? If the limit exists, the two-sided limit exists, that implies the one-sided limits are the same, and f of a must equal limit. All right. Here, hopefully you should have one totally a subset of the other. It's easier for the limit to exist than it is to be continuous. The continuous has more conditions. I wasn't clear in my directions if I meant name a function or draw a function. So I'll take either a named function or draw a function graph. A function on here, wouldn't you agree that the limit does not exist and it's not continuous? So if you had anything like this or anything, that's just an example. It doesn't have to look like that, obviously. Okay? Do you agree the limit doesn't exist because the one-sided limits are good? In here, the limit exists, but it's not continuous. What kind of graph would that look like? Give me something where the limit exists, but there's no continuity. A hole, yeah. If you had something with a hole, that would be great there. And then continuous, shoot. You can graph a million graphs for continuity. This guy, the roots were supposed to be 1 equals, not very well. What were the roots? X minus 1 and x plus 2 or something like that? Minus 1. So x plus 1 and x minus 2, like that? Is that right? Okay. Yes. The factors are x minus 1 and x plus 2, yeah. What about somebody who does this? There you go. There's my y-intercept of 8. True or false? You need a counter argument there at least. Why doesn't that satisfy? Yes. Yeah, the y-intercept of that is not 8, it's 6. So that person's obviously thinking, oh, I'll just throw a constant in, and that's the y. No. When you plug 0 in, it should be that. Furthermore, they had their roots right, 1 and negative 2, and then what did they do to their graph? So they don't even have the roots right now. They just moved everything. That is definitely not it. Instead, you want to stretch it, and you stretch by virtue of a coefficient. You agree? Finding that a. What was your coefficient? 4 maybe? I think you had the answer to that, so you should be good there. Here, sorry, if you just gave these a go, you're good. I'll give you the answers. Unless you want me to put the answers up there. If you want to stick around, great. If you want to leave, fine. If you're not confident in here, you might look, but otherwise you're fine. Have a nice day. Make sure I get by the end of the day and get you the things you got for work on second science, 7th period. Thank you. Have a great day. Oh, that's cool. Have a wonderful day.
Are you today? Where are you?
All right.
What do I do?
Oh,